Hello, everyone. You're welcome to another session, another SQL session. All right. So today we would be talking about some functions, or I would say some commands that are used for data retrieval. So let me say data retrieval. All right. Let me maximize this. All right. So when we say data retrieval, we are talking about it's just the way it is, like getting information from the data or from the database, how different methods that are being used in getting this information. All right. So we will talk about distinct. All right, we'll talk about distinct. We'll talk about we'll talk about we'll talk about order by, we'll talk about limits, and we'll talk about something else. We'll talk about like. All right. So let's head up and let's start with distinct. When we say distinct, we mean something that is unique, right? So there's nothing much to explain, but that it is unique. It is easier to explain it in the practical terms. Okay. So let's see what we mean by that. Okay, so I'm off to my Jupyter notebook, and as usual, I'm using the SQL magic command. So we'll do SQL in lower cases, and let's see select. I think this also needs to be zoomed so we could see properly. Okay, so let's see our select clause. Let's see our select clause. All right. Um, so let's select all from student registration, student registration, okay, and boiler. So we have this data set for student registration, and what we want to do here is to see distinct. So now let's look at something here. Looking at location. Let me use location. So let me call out location. All right. So I would continue with the SQL magic, and I would say select location from student registration. I believe that is it. Yes. So now we have 30 rows and we have location. We have a lot of Nigeria, we have Canada, Ghana, South Africa. Yes. So we have different locations. Okay, and we can see repetition of locations represented in this column, right? Which is kind of redundancy. Like that is what we could just it's kind of redundant, so we call it redundancy, right? So we have a lot of duplicates in this column, and this is not exactly what we want. Yes, we want to see the location, but we also need to see we the location we want is more of, I want to see the areas, the areas, the um countries or states. In short, I want to see the locations where our students are registering from. Okay, so I have seen Nigeria. That should be enough for me. All right. So you don't need to give me more of the Nigeria locations. Okay. So I just need one to represent that yes, Nigeria is one of the countries that our students register from. Okay. So now to do that, it's where we would introduce distinct function. Okay, so let me just use this. Okay, now all I just need to do is to write distinct. Okay, I'll just write distinct with a space and location. And when I run this, I am seeing that everything has now been shrinked to just 9 countries. So I could see 9 rows affected, right? So everything has been shrinked to a list of 9 countries. So with this, I can know that, oh, all right. So most of my students or all of my registration students are coming from these countries. So you can see that the entire 30 rows of countries are now shrinked into nine. So one representing some numbers of countries or some numbers of students. All right. So this is the function of distinct. So distinct is one of the were very beautiful and important retrieval method that SQL uses. Okay, so to bring out more of unique values. All right, so that is distinct. Okay, so let's go to this. The next is order by. All right, now let's look at this distinct and let's run another command. Let's say we have, okay, let's just still call our query here. This is the entirety of our table. We can see that the only thing that is in proper order is probably the ID column, all right? And that's because we use the serial data type, okay, not exactly data type, but we use the serial constraint, okay, to bring out this. So it was bringing out the number serially, and that's why it's looking like it is in an ordered state, okay? But you see, every other thing doesn't really have a particular order. That is why we have something called order by. Now, this is how the magic of order by happens. When we include the order by here, we do select all from student registration. Now, what do I want to achieve? I want to see the first name, coming up in alphabetical order. All right. So when I do order by and I write first name and I run this, okay, so you can see there is a first name that is 20%. I think that should be a nickname, kind of. All right. So, but you could see that because numbers are kind of seen as something that precedes alphabet, so you can see that 20 becomes the first. All right, and then you keep on seeing the A's. Then after the A's, because there is no first name beginning with B, so you now see a C. Okay, you could even run order by with two columns. All right, so I could say order by first name and I would say last name. All right, so what this does is it considers the first name. All right, and then maybe um if there is a kind of conflict, probably we have two first names together, it then orders it based on the sequence from the surname. Or yeah, from the surname. Okay, so let's see if we have something like that. So I think there is a name Thabu. Yes. Now look at this. These are two similar first name, the same first name. Now this is the last name. All right, so we have M and they have an M. We have O, this one also has an O. We have D, and this is a K. So this now, because of the letter D, makes this um, earlier than Mokwena. All right. So Modise becomes first, and then the other becomes the next. So this is what you could achieve. You could add multiple columns, and it continues like that the way you ordered them. So it will check from the first name, and if there's a kind of conflict, maybe similarities or duplicates of a first name, it goes to the last name and then rearrange it based on that order. All right. So that is what order by does. Okay, in terms of arrangement. Okay. So aside that, we could also look at something here. Let's say we want to order by the age. All right. So say we do age and we run this. So you can see this is now scattered, the first name, the last name, because the consideration now is the age. All right. So you can see that the minimum age is 22 by this. Oh, now I need to tell you this also, that the default order for the order by command is ascending order. However, you could make your order by descending order. You could put it in a descending other stage. Okay, um, more like if I want to do that, probably I want the highest or the oldest person to be the first on the list. And it could be, so I would just put DSC, okay? And that is all, which means descending. So when I run this and I come here, I would see that the oldest person here is 32 years old, okay? So he is 32 years. And this, you continue seeing it reducing as it goes down, and 22 should be the last because that was, yeah, so you can see. So 22 is the last because that is the least. So this is your order by in descending order. If you use ASC, it will give you ascending, all right? But we don't really put it, we don't put it because by default, with or without it will be in ascending order, all right? So, but if you want it to descending order, then use your DSC, all right? So that's the same way you could do for the names, like we have, like we did with the first names initially. So we have first name, right? So when we check this and we say we want it in descending order, that means the alphabet, if there is a name with a letter Z, okay, then that name should be the first, okay? So when I run this, I would see, oh, there is a name. So we have Zara, ZYWT, down to A. So the A names would be the first, okay, or will be the last on the list because it is descending. So this could be used for different methods, all right? For example, I'll probably want to know like what we did. Maybe I want to know the oldest person in this place, so I would just use age and I will do descending. All right. So when I run this, I do not. Okay. Okay. So I did remove this. So I'll do age and I'll do descending. So when I run this, you realize that I could just say, okay, so these are the five oldest persons in the class. All right, so it will be easy to query that. All right, so that is the importance of order by. So it's more for the sake of sorting. Okay, so you're sorting your record in a particular order. So you could use any column, you could use multiple columns to run the sorting. You could use either in ascending or descending form. It's best, okay, it's best for sorting. Okay, so that's the recommended um, keyword for sorting in SQL. All right, so I believe we've understood order by. Now, limits is another interesting data retrieval method used in SQL. Okay, so what does limit do? What does limit do? So limit does what it says. Limit. So it limits the data retrieval pattern. Okay, it limits the number of rows to be seen or to be displayed. All right. So I will do this now. Let me continue from this order by. So now I want to see the oldest persons. I want to see like the five oldest persons in the class. All right. So I have done my order by age in descending order. So if I put limits and I just put five, it will give me the five oldest people. So it will just check one, two, three, four, five, and cut the list from there. So when I run this, you can see it has filtered my lists, it has filtered my table to one, two, three, four, and five. Okay, it's as simple as that. For example, I want to know the oldest person in the class. I will just limit it to one. And when I run this, I just have this name. And because the order is in descending, so it is going to show this. So this person is 32 years. She person is a female from Ghana. She joined through a referral link, and this is the person's name. All right. If I want to see the youngest person, just one, the youngest person. When I do, I don't need to put anything like I said. So I will just remove this order by age by default to be ascending. So we expect the first list, the first item, or the first record on the table to be the youngest person. So when I run this, I'll see Jessica is the youngest person, and source of journey was linked in the age is 22 because 22 is the youngest person here. All right. So this, we could increase it and say maybe let's say for the young four persons, and we have 22, 23, 23, 24. Okay, so these are the youngest persons. All right, the four youngest person. Okay, so this is practically everything you need to know about limits. All right, so whatever you're going to do, this is how limit is being used. Okay, so but always remember the order of things. Okay, limits is limits is always the last keyword in your query. Okay, limit is always the last keyword in your query. All right, so we have order by, it depends. So I think in one of our sessions we talk about order of execution. All right, so and the arrangement of this, so you don't just put these things somewhere, you need to put it in a certain order. So from student registration, you're ordering it by the age, then limit the results to 4. Okay, so that's what it means. All right, now let's see what we can touch again. So we're talking about like. Let me just remove this so it won't confuse us. So we're talking about like. We have touched distinct, we've touched order by, touched limit, and now we're talking about like. Like is a very interesting one. So like, I would like to do this. Okay, so when we say like is just is a kind of um filtering. It's more like it's filtering based on a pattern. Okay, so and it uses wildcard. It uses wildcards. Okay, when we say wildcards, we're talking of the likes of the percentage, um, percentage and underscore. Okay, we are going to see that in action. All right, so when we say like, we are trying to filter the record based on a particular pattern. Okay, so for example, I'm saying select, let's say select all. Okay, let's say select all from student registration. This is it, right? Now we have all these names. I want to say something like, so you have to use a where clause, okay, because you are filtering based on a condition. Okay, so the it's just that in this case the condition is a pattern kind of condition. We are using a pattern to call the condition. Okay, so we are going to say where the operator now is going to be like, okay, and then we are going to put it in colon, in quote. Okay, so now because like is the pattern is mostly textual content, so they are mostly, we expect them to be string like. Okay, so because the numerical columns have plethora of ways to filter based on their own patterns, so that's, you don't need like to do that. So when you see like is used for pattern's sake. Okay, so it's used for strings. Okay, for strings. All right, so I would say something like, where like, and say I want to see people whose name starts from A, first name starts from A. So I'm not just going to say where like, I would say where I need to call the column first name. Okay, like, and if I say A, I would say A and percentage. Now, what percentage means is, percentage here stands for, um, let me just, let me do this. So percentage here stands for all characters, or I would prefer using any character. Okay, and underscore here means one character. So I think the all characters should work better. It should be more explanatory. All right. So now we have this. All right. So what I'm saying here is it starts with an A, but with this percentage on the right means any amount of character can come after this. I don't care. but my interest is that it should start with an A. So when I run this, I would see that the first name, because that's the column I'm filtering based on this, is going to show only names that starts with an A. All right, only names that start with an A. Now, what happens if I put the percentage symbol here? If I put the percentage symbol here, what it says is it can start with anything, but it should end with an A. That's what it means. So start with anything, but you have to end with an A. All right. Now, if I run this, I have an issue. It's showing that there is no record for that. Is that possible? Let's check. Let's check the main record. Okay. Oh, I think this was the main record, right? Do we have? Yeah, I think this is it here. So now let's see. Is that we have okay, let's see, the first name is there's Jessica, there's Amanda, it's ends with an A, there's Akosua, so there are some names here, Ayana that ends, Aisha that ends with an A. So why is our query not giving us records? Okay, so if you look deep, you realize that it's because postgres is case sensitive. Okay, so we if we want it to be case insensitive, then we have to make it I like instead of like. So when I run this, it doesn't matter if it ends with a capital A or a small a, it will just make sure it ends with an A. So when I run this, you can see my list comes back, and I'm seeing that all the first names that are listed here ends with an A. Okay, so now let's try something else. If I put these percentages on both sides, I believe you should be thinking something now. All right. So if I put it on both sides, what it means is that anything can come from the left, anything can come from the right, but I want an A to be in the midst of this name. So wherever the information is coming from, it must, wherever the letters are gathered, however they are arranged, but whatever spelling, okay, that is in the first name, it should have an A in the midst of it. Okay, so when I run this, interestingly, you are seeing an A. Okay, there is Amanda here, there's Kwame here, there's an A. You can see that there's an A at the beginning here, there's an A at the end here. So it doesn't mean that the A must be at the middle. Okay, what it means is whatever position, there should just be an A in this name. Okay, so that's why you can see some names that has A at the end, A at the beginning, so but they are still valid here. All right, so that is what this means. All right. Okay, so yes, so that's what this means. Now, we said there is an underscore as well, right? So let's see what the underscore does. The underscore, handles, let me just leave the A here. It handles, some, it does a character. So if I put one underscore, that means it is a character. So, but doing one underscore here means that there are two characters, okay, but it should end with an A. So I have restricted it to the number of characters. So I'm saying there are two characters and it should end with an A. Unfortunately, I don't have a name that has just two characters. Okay, so let's see. So I'm going to do like three underscore. So please plus this A, it should be four. Okay, for characters. So I'll do one, two, three, and when I run this, okay, what happens is not showing. Okay, probably I don't have four character words that end with an A. So let me add one more underscore to make it five, because I think we have Asana, Asana, five. Yeah. So when I run this, oh yeah, so we have Amina, Ayana, Aisha, Zara. All right. So we have this, all right, we have this, so it means, so the number of underscores is, you are restricting your pattern to say that the number of underscore plus the letter you put there should be what needs to be represented as the names that you're looking for, okay? And it should end with an A. All right. So if I do an A from the beginning, if I do an A from the beginning, so these are four underscores after A. So that means it should start with an A and end with any four character. So do we have that? Yes, we do. All right. So this is what it is. You could put it in the middle. You could say, okay, if I do that in the middle, I'm saying that I should have one, two characters. Then I should have an A after the two characters. Then I should have two more characters after that. Do you have something like that? Yes. So you see, we have Kwame, two characters before an A and two characters after the A. Thabo, two characters before the A and two characters after the A. So these are different patterns you could use to retrieve data from your database. I hope you enjoyed this session and we will meet in other sessions. Thank you very much.